It said go now, so I
Maybe
can go now.
maybe sometimes you on green.
Sometimes I go when it's not going, and then it's like, oh wait, I gotta go when it says go.
Yeah.
Yeah, yeah. Okay, so tomorrow, mañana.
Yeah.
Mañana. Mañana. I don't know what it is in German. Tomorrow in German. That's a good day. I knew that one. Right. Tomorrow's testing. I'm not gonna lie to you. Your test is 4 sides of a piece of paper. So it's two pages, or 2 sheets, I should say, 4 pages. Okay. But there's room for you to work. It's only 19 questions. Okay. But could I give? I'm the test writer, and I like to give you guys space to work. Really explore the space. Okay. All right. So that's tomorrow. Okay. Also tomorrow is you've got 2 homeworks that are due. Purple, very purpley this week or this unit. So you've got 2 purple packets. One is the P1, 2, 4, and 5 worksheet. Okay, that was from a couple of weeks ago. And the second is the Chapter P review worksheet, which you got last week Friday. On top of those 2, you also have 2 formatives that if you haven't turned those in, you need to turn those 2 in also. Okay? So you've got 4 things to turn in prior to your 4-page test tomorrow. The rule of the 4s. Okay? All right? So you've got that going on. Okay? Today, what we're going to do is we're going to quickly just learn the basics today of matrices. Because matrices is on the ACT, and it's in like programming and things of that nature. So we're going to learn the basics of matrices today, and then we'll get more involved in the matrices after tomorrow. Okay? So we got that going on. Good times. All right. So we call this chapter Q, just because we needed something after P before we get to chapter 3. Okay? So, I mean, if you want to call it chapter 2, that's fine, but really it's chapter 2. Why? I really don't know at all. Just to be alphabetical, I suppose. So a matrix is a rectangular, that's key, that it's a rectangular arrangement of numbers organized into rows and columns. Rows and columns. Very important. Rows by columns. You'll find that later on as we get more involved. Matrices are named, okay, just like you have. Matrices are named with capital letters. So capital A would be matrix A. The individual numbers that make up a matrix are called elements. So, for instance, when you see the name, the letter, the capital letter of a matrix, in this case it's matrix A, a lot of the times you will see 2 numbers right after it. Okay? And those 2 numbers are the dimensions. So matrix A has 2 rows and 3 columns. Okay? So it's got 2 rows and 3 columns. So there will be 6 elements in matrix A. Okay? Now, on top of that, each element has its own specific address. Just like you have your own specific address of where you live. So for instance, the element of 3 lives in the first row, first column. So its address would be A11. Because it's in the first row, first column. -5, an element in our matrix A, would live in row 2, column 3, so its address would be A23. And so on. Rows, remember, are horizontal. Columns are vertical. Matrices have brackets or parentheses. We just learned that because of the coding aspect of using matrices and coding, that they sometimes use big parentheses around them too, not just brackets. Okay? So either one works for us, brackets or parentheses.
And there's no difference.
There is no difference. We just learned that. Really, it was that. Already. Good to go on this page, on this slide? Okay. So here's what I was saying about the parentheses. Both of these are matrices. Okay? Right? And so they both are exactly the same. They both have the exact same dimensions. What are the dimensions of this matrix? 3 by 4, 3 rows, 4 columns, 3 by 4. Yep, 3 by 4. Where does the element 7 live? 2, 2. Okay. Row 2, column 2. Okay. I would agree with that too. Now, it would be hard to say, where does the element 5 live? Right? Because you could say that the element 5 lives in row 1, column 2. I could say that the element 5 lives in row 2, column 4. And somebody else could say that the element 5 lives in row 3, column 3. Okay? So we have to be, so when we're asking for those things, we will have specific, unique elements in those. But just know that the same number can be in different elements. It doesn't always have different numbers. Okay? Love it. I don't think there's anything else out here. Nope, there be not. Okay. All right. So we have some operations that go along with matrices. Okay? We will deal with 3 of the operations today. The first 2 are addition and subtraction. The other one is called scalar multiplication. We also have matrix multiplication, which we'll deal with on Friday. And then we've got inverses and determinants and all that fun stuff to go along with them too, but that's later on next week. Okay? So we're going to deal with the basics of the basics first. Addition and subtraction. The rule is this, right here. Right here. The two matrices must have equal dimensions. If they don't have equal dimensions, you cannot add or subtract them. It is not possible. If they have the same dimensions, then you can do it. If they don't, you're done. Okay? So if this was a 2 by 2 matrix, which we have two 2 by 2 matrices, if this was a 2 by 2 matrix plus a 2 by 3 matrix, can't do it. Not possible. Okay? They have to have the same dimensions. Okay? And a lot of the times what I'll do is I'll write down underneath here, well, that's a 2 by 2 matrix. Well, that's a 2 by 2 matrix. Those are the same. Okay? Then, once you have established the fact that they are exactly the same dimension, it's just as simple as adding or subtracting the corresponding elements. What I mean by that is the dimensions of the result are also going to be a 2 by 2. Nothing changes. But then what you do is you take the first row, first column, and you add it to the first row, first column of the other one. In this case, it's 4 plus 2. Then you take first row, second column, first row, second column, corresponding, 0 plus 7. Then you take second row, first column, -6 plus -1. Then you take, and you keep doing this process until all of your elements have been found. And then you just do the math. So this would end up being a 2 by 2 matrix. Now, I forgot one very crucial thing to tell you about matrices. How you read them off to somebody else. Okay? How you read a matrix is exactly how you read a book. Left to right, top to bottom. Okay? And you're going to pause after every row. Okay? So how I would go about telling you this matrix is I would first tell you the size, the dimension. So this matrix is a 2 by 2 matrix. It has elements of 6, 7, -7, and -3. Size first, so that you as a listener knows what to do, and then you go left to right, top to bottom. Questions on it? Good times. Okay? You try this one. So I get 3 minus -3. I get -5 minus 0. I get 10 minus -2. And I get -4 minus 4. So I get as a resultant matrix, the 2 by 2 matrix, 6, -5, 12, -8. Do we have an accord? Yes, ma'am. It's a subtraction one. Those darn operations get you every time. Good? Okay. See, there it is. Boom, boom, and boom. We've done it. Okay? So the last operation that we would like to do today is something called scalar multiplication. Okay? And scalar multiplication is where you take a matrix and you multiply it by a real number. Okay? Now, for lack of a better terminology, I think is the best way of saying it, for lack of a better terminology, the easiest thing to do here is simply distribute. So this number out in front, this real number out in front, needs to be distributed into every single element inside the matrix. Size, again, doesn't change. Okay? So 3 times negative 3 would be negative 9. Negative 3 times negative 3 would be positive 9. Negative 3 times positive 1 is negative 3. Negative 3 times negative 1 is positive 3. And there is your resultant. Now, what we can do is we can put those all together. Okay? So if you have a scalar multiplication and along with an addition, so order of operations would say you would do the multiplication first, then you do the subtraction. Give her a whirl. So that would be 8, 12, negative 4, and 20. And then that would still be minus 6, negative 4, 1, and 5. And then, so 8 minus 6 is 2. 12 minus negative 4 is 16. Negative 4 minus 1 is negative 5. And 20 minus 5 is 15. Yes? 2 by 2 matrix, 2, 16, negative 5, 15. Good. Good times. Okay? Now it says practice worksheet 2-4, but we haven't given it to you yet, so because we're not going to hand it out until Friday, because yeah, we're not. It'll be over there if we would have done it. So we'll hand out the homework on Friday because we want you to focus in on reviewing for the test. So for the remainder of the time, because we have a good chunk of time left over, I am here for questions on formatives, purples, anything in preparation that you need for tomorrow's test.